At the very top, it says build an atom. You want to click onto this one. And your simulation should get started. So what you're going to do is you're going to use, I'm going to leave this on my screen. Put this down here. I can, nothing's working right now. Let's see. This over here. Okay. So if you look at the lab instructions, the first part is you're going to click on the link above, and then you're going to basically use this to help us build the isotopes. And then what you're going to do is you're going to tell me the mass number of the isotope. You're going to tell me the atomic number, the number of protons, the number of electrons, the number of neutrons, the net charge, and then the whether it's stable or unstable. Okay, so the first one is, if you look at it, it's, let me put this up here. It's going to be oxygen 19. So the isotope is called 19. We've talked about isotopes, right? So what does that 19 mean? Anyone remember?
Isn't it the mass of protons? Or how many protons they were?
Well, no, it's not the number of protons there were, but it's the number, it's the mass. You're right, it's the mass. It's called the mass number. So it's the mass number represents the sum of the number of protons plus the number of neutrons. Okay, so the mass of the atom is basically the sum of the protons and the neutrons. Okay, so if we look on our table, I'm going to do this. See if I can put them both on the same screen here. Okay, can you guys, so are you guys able to see that? Okay, so if I look on the periodic table, oxygen has how many protons? Does anybody remember how to calculate that? Let's pull up the periodic table then. Okay, so we're going to look at oxygen.
Isn't it 8?
That's right. It has 8, right? So this here represents the atomic number. The atomic number always represents the number of protons. So we know that it has 8 protons. So if we go back to, I'm going to see if I can separate. Crap. Did I launch? There we go. Build an atom. There we go. Thought I closed it. Okay. So we know we need 8 protons. 1, 2, 3, 4, 5, 6, 7, 8. Now it shows us the element that's there, right? So in my example, I'm going to fill out the screen here. So now we know that we have a mass number. You guys told me this is the new mass number, so that's 19. The atomic number, which was what?
8.
8. The number of protons, which is?
8.
8. Okay, the number of electrons. Okay, so
I'm not sure. I think it was 8. Doesn't it stay the same?
It's close. You're close, right? So it would normally be 8. This number here, this here tells me I have 2 negative charges, right? That means I'm adding 2 more electrons. So normally I would have 8 because 8 would balance out the 8 positive charges, right? But now I have 2 more added onto that. So I have a total of how much?
10.
10. Does that make sense? Because electrons are negatively charged. Now this isotope has a negative charge associated with it. It has a -2 charge associated with it. Okay, are you guys with me so far?
Yes.
Okay, so the next part is the number of protons. So how can I calculate the number of protons? The number of neutrons that this guy has.
Isn't it like the mass subtracted by like the number of protons, right?
That's right. It is the mass or our mass number subtract by the number of protons, right? So 19 minus 8. Okay. Let's see. What is 19 minus 8?
8.
19 minus 8 is 8?
11.
11. Okay. So let's keep going. Let me make this a little bit bigger. Okay, so the next part says the net charge. So what was the net charge on it? Are you guys there?
I'm not sure what the net charge is.
Okay, so remember, if it had, normally it would have 8 protons and 8 electrons. And so the net charge on that would be 0 because the electrons and the protons balance each other out. Now we have 10 electrons and 8 protons. So what would be the net charge? So electrons are what charge again?
Negative.
Negative. So okay, so right now we have 10 electrons. That means I have -10 charges, right? So, and then I have how many protons?
8.
So I have +8 charges. 8 minus 10 plus 8 is going to equal?
-2.
-2. So my net charge on this is going to be a -2 charge. Do you guys get that?
Yes.
Okay. So the next part is it stable or unstable? So the way that we determine that is by, let's put in our number of neutrons. We were putting in 11 neutrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 10, 11. And then we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so then that tells me it's a negative ion. So our net charge is a -2. Our mass is 19. Okay, the next part, is it stable or if it's unstable? If we click on this, this lets us know if our molecule is stable. Now the stability is a result of the neutrons. The neutrons are used to stabilize the structure. Okay, so is this guy stable or unstable?
Unstable.
Unstable. Okay, so then we would write unstable. Let me put that back down. That's for oxygen. Okay. So do you guys get that?
Yes.
Yeah.
Okay. So you got to do the same thing for these guys down here. Okay. So can I clear my screen? Then I'll show you the other part.
Yes.
Okay. Everybody got it down?
Yeah.
Okay. Okay. So part 2 is you're going to try to find 2 stable isotopes for each of the following elements. We're doing fluorine, carbon, and beryllium. Okay. So if we're doing fluorine, how many protons does fluorine have? Anyone? How do I calculate the number of proteins? I mean, not proteins, protons. Long day. Protons.
Is it the atomic number?
It is the atomic number. So what is the atomic number of fluorine? Let's pull up our periodic table. You guys know you can go to P-Table. P-Table is located right here at ptable.com. It's also, there's a link in my syllabus. Okay, so it has how many? This here represents the atomic number up top. It's right here. 9, that's right. Okay, so we want to put in 9. 1, 2, 3, 5, 6, 7, 8, and 9. We know that we have the same amount of electrons because it's an element is going to be neutrally charged. Okay, and then we're going to hit this part here. So right now it has no neutrons in it. So we're going to add enough neutrons to make it stable. Okay, so that one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that has 10 neutrons. So our mass, our new mass number is 19, which is just happens to be the right weight for fluorine. So then I would write for my answer, one of my stable isotopes would be superscript. Superscript means above. Okay, so it's a little bit above, smaller numbers, but a little bit above the F in front of it. So superscript 19F. So that would be one of them. Okay, so let's see if I add one more, what would happen? One more neutron. That's unstable. That's unstable. That's unstable. So let's take those out. 1, 2, 3. Okay, that was 19. Okay, so then that means that in this case, there's only one isotope. So I would write down there is only one stable isotope. Okay, that's it. You see how that works? So now you guys have to do for carbon and beryllium. Okay, questions?
No.
Okay, good. Okay, the last part of the lab. Yeah. I have to go back to my original. Okay, so click onto game. So here, let me make this a full screen. They want me to find the element that has one proton and one electron. What element has only one proton?
Hydrogen?
Hydrogen. So I'll go ahead and click hydrogen. And they ask, is it a neutral atom or is it an ion? It has one plus charge and one minus charge. Is that going to be neutral or is it going to be an ion?
Is it neutral?
It's neutral. So I got it right. Okay, then I hit next. And so what I want to do is I want to complete all 4 quizzes. So I'll have a screenshot at the very end with my score for each of the 4 quizzes. Okay. And then I'm going to include that in my lab report. Okay, so let's do this one real quick. So we have 9 protons, 10 neutrons, and 10 electrons. So what element is going to be 9 protons?
Fluorine?
Fluorine. Okay, is this guy going to be neutral or is it going to be an ion?
Is it going to be an ion?
It's going to be an ion because we have one more electron than we have protons. You see how it works?
Yeah.
Okay. Okay. So you're going to do the same thing here. The only thing now, you get the calculator. It says, what is the total charge? We have 5 protons, 5 neutrons, and 5 electrons.
Is it asking if it's neutral?
That's right. So you're going to have a 0 charge, right? The total charge is going to be 0. Okay. What is the mass number? It has, you look at it in the center, we have 2 protons, we have 2 neutrons, we have 2 electrons. So what would be the mass number? Okay, we know that mass number is the sum of the number of protons plus the number of neutrons. Does that help?
Is it
What
4?
would it be? It'll be 4. Let's do one more. What is the total charge? We have a neutron and a proton.
Is it 1?
Positive 1?
Yeah.
Okay. That is correct. You guys are on fire. Okay, what about this next one? What is the number of, I said, what is the number? I said, what is the mass number?
15?
And the last one for the goal. What is the total charge?
-2?
Simple. Okay. So you're going to do the same thing here and go through and answer those questions. So this guy is sulfur, right? So this is sulfur. This here would be the atomic number. Up here is going to be our mass number. So what would be the mass number up here? What would be the mass number if we have 16 protons and 17 neutrons and 18 electrons?
Is it 33?
Okay. Piece of cake, because we know that the mass number is just the sum of the protons and the neutrons. Okay, now they want you to determine the charge. Okay, we have 14 protons, we have 16 neutrons, and we have 14 electrons. So what would be the charge on the silicon?
It's neutral?
Neutral. God, you're on fire. Okay. One more for the road. Okay, so this one, they want us to determine the atomic number for the
Hydrogen,
protons? It's hydrogen. So what is the atomic number for hydrogen?
1.
Okay. So the key is that the atomic number defines what the element is as well. Good job. Okay, piece of cake?
Yeah.
So that's it. So if you guys get that done, oh, and there's one last question. This one is a brain teaser. So I can't give you too much information. I want you to use what you know and use the notes from the last lecture to help you do the calculation. It says Johnny and Bernice discovered a new element. It's called, that's a typo, let me fix that. Is called jovernicium, and the symbol is JV. Jovernicium has an atomic number of 120. It has 3 isotopes. It should be with the following abundances. And then it gives you what they are. Calculate JV, average atomic mass. Based upon the average atomic mass, what would be the number of protons, neutrons, and electrons it would have? Okay. So that's the only question that you guys have to answer, and just fill out the rest of it. Pretty simple.
Should we do this just on a Google Doc?
Yes.
For the little quiz thing that we were doing like not so long ago, is there a link posted up on the page?
Yes, the link is actually in the lab. Okay, let's see if I can find the lab. There we go. Yeah, so the link is right here where it says build an atom. So it's all part of the same thing. So the quiz, the game is at the end. And I think in theory, you should be able to get there from here as well too. If not, oh yeah, it's right here at the bottom.
Thank you.
Okay. Any other questions? Great. Okay, anybody want to give me cash? I'll take $1 million now. Call it a day. No, no cash? Stingy. Okay, so I'll let you guys get started. And I'll be here to answer any questions if you guys have any.
As for the screenshot, so we just need like a screenshot from like the first part that we did when you were like putting like all the neutrons and electrons together, and then for like the game.
Yep.
Okay. Just making sure. Thank you.
I got here kind of late on the first part. So I kind of didn't really understand it. If you could do one more problem, please.
Yeah, sure. So I won't do one more problem because then I'll do the whole thing for you, right? I don't want to do that. But
Or go over the same problem.
we can go over the same problem. Okay, let me pull up the lab. Okay, so the very first part of it is that you need to fill in the table, and you're going to use build an atom to do it.
Mhm.
Okay, so then the first part is the mass number. So what is the mass number for?
The neutrons and protons for oh shoot.
For this?
Wait. The left number, it's the 19 or
That's right. It is the 19. So that would be the mass number. Okay.
Mhm.
So what is the atomic number for oxygen?
Is it 8? I don't remember right. I don't have my
That's right.
It is?
It is 8. That's correct. Okay. What would be the number of protons?
8.
Okay. What would be the number of electrons in this case for this particular?
10.
And that's correct. The number of neutrons?
That one I wouldn't. Oh wait. 8. What is it? I can't even do math right now. 11?
11. Okay. Okay. The next part is the net charge.
And that one I'm not too sure. So I just put like the -2 or?
That's right. It would be -2.
Okay.
Right? Because we have 10 electrons minus 10.
Yeah.
So, okay. So then if we go ahead and put in what we were supposed to put in, so we'll have 1, 2, 3, 4.
And then to submit it, do we take the screenshot off the page as well?
Yep.
Or do we just do it off like the lab?
You can take the screenshot. The screenshot will work as well. So and just include that in your lab. Oops, I got carried away. Oxygen. Okay, and then 1, 2, 3. That's 3, 4, 5, 6, 7, 8, 9, 10, 11. And then electrons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so then it tells us right there that it's an ion. If we click on this, this will tell us our net charge. Let me see if I can slide over. Okay, so our net charge is -2. And then if we want to see 19 was our mass number, we want to see if it's stable. So that would be unstable. So in that last column where it says stable or unstable, you're going to write in unstable.
Alrighty.
Okay.
So when it's unstable, it's just as long as it has an ion? As long as it's
No,
an ion?
it doesn't have anything to do with it being an ion. It has to do with the fact that you have more neutrons. Too many neutrons.
Oh, okay.
Too few neutrons. So in this case, you have too many neutrons, it makes it unstable. And so that wouldn't be a naturally occurring isotope.
It's in correlation of the protons, I'm assuming?
No, it varies. It just varies in terms of stability. Yeah.
Oh, okay.
So nobody has there's no rhyme or reason why. Some of them take a little more neutrons compared to protons, but nobody knows why yet. So,
okay.
My guess, there's some type of structure involved in it, and there will be something figured out once we're able to see at that scale. So.
Got it.
Yep.
Alrighty, for sure. Thank you.
No problem. Okay. Gabby, do you have any questions? Gabriella?
I'm trying to just see, catching up. I just joined right now.
Okay.
So I'm not sure what you guys are working on.
Okay, so it's the new lab. So if you go to lab number 4, it'll be under modules. It'll look like this. Pull it up. And then if you click on that link, it'll take you to this site right here. Oops. It'll actually be like this. Hold on. It'll take you to here. So then you want to click on the very first one, the atom. Reset this. And so you're going to use this to fill in the information down here.
So lab number 4, I'm trying to find that one.
If you go under Canvas, under modules,
Okay.
if you go under the second, it would be unit 2.
Activities. Hold on.
No, unit 2.
Oh, unit 2. Got it.
Oh,
lab. I found it.
Yep.
Start assignment.
Yep.
Oh,
Well,
hold on. No.
No, you don't want to start it. You're going to upload it when you're ready to upload it. Okay, but you're going to click on this. You see that link up top where it says build an atom?
No. Oh, an atom.
Okay, go back. You want to share your screen?
Yeah, let me share it.
Let me stop sharing mine.
Okay, so I'm in unit 2.
Okay, so
Right,
click on it. You see where it says lab 4?
Right here?
Yep, click on it. Okay. Now
Oh, this one. I see it up
Yep.
here.
Okay.
And then click on atom.
Yeah. Okay, so then what I would do, I would drag it out so that I can see the, it says where it says lab 4, the lab 4 tab. I'd pull them separately so I have them right next to each other. So I'd be able to answer my questions. Okay.
Perfect.
So both are together for the first one. Okay, so we have oxygen 19, 2 minus. Okay, so the 19 represents the mass number. You remember what mass number is?
Have to look at my notes.
Okay.
I don't remember on top
Okay.
of my head.
So the mass number is equal to the sum, or it's the number of protons plus the number of neutrons.
Okay.
And it also represents the mass of the, or an estimate of the mass of the atom. Okay. So the mass number, you got to write on your board here. The mass number is that number up top right there.
Okay.
Okay, so what would be the mass number for this element?
The 19?
Yep. Okay, so the next part is the atomic number. So do you have your periodic table?
I'm so unprepared.
Always in chemistry, you should always have your periodic table ready. So do me a favor, hit your plus tab up here. And go to P table. ptable.com. It's all one word, table.
All together?
Yep. So it's ptable.com. Okay.
Oh, right here.
Okay. So now we were looking at oxygen. So the number right here at the very top, that number there, that's called the atomic number. Okay. So that represents the number of protons, the atomic number. Okay. The atomic number defines the element. So no two elements will have the same atomic number. Okay. So if we go back to our lab, okay, so the atomic number was what?
8.
Okay, so I'd write 8 there. And you can annotate on your screen as well too. So what you would do is hit at the top, it'll say view options. You click on that, it'll say annotate. You want to click annotate. And then you'll have text, draw. So if you hit draw with the squiggly line, it allows you to draw.
Right here, I see that. Oh, okay, cool.
Okay, so the number of protons. So what did I say about the atomic number?
That they're never going to be the same?
That no two different atoms are going to have the same atomic number. So oxygen is always going to be 8, and I said something else. That the atomic number equals what? Okay, I'm going to give it to you this time. The atomic number equals the number of protons. So how many protons does oxygen have?
Does it say it right now? Oh, just kidding. How many protons does it have? Is it the 8 or is it the 19?
It's the 8 because the atomic number equals the number of protons. You get that?
Yes.
Okay. So.
Wait, how did you annotate again?
If you go to the top where it says view, like you're viewing Gabby's thing, it'll say view options, or it'll be ... or it'll say options, or it depends on the type of system that you have. Then if you click on that, it'll say annotate, ANNOTATE.
Oh, okay, got it. Thank you.
And you click on that, and then you'll have a text box, you'll have squiggle, draw, you'll have stamp, all that. Okay. Okay, so the number of electrons for an atom that's neutral, it's going to be equal. So we'd have 8 electrons if it had a 0 charge. But this guy has a, what do we see over here? I'm going to do that.
A 2?
A -2, right? It's 2 negative, right? So the 2 negative means a -2, right? So that means that we have 2 more electrons. So if we normally have 8, because 8 would balance out the protons. Protons are positively charged, electrons are negatively charged. An atom has to be neutrally charged initially. It can be an ion, right? And so this is an example of an ion. So that means we have 2 extra electrons, okay? So we would normally have 8, and we added 2 more. That's a total of what?
And we added 2 more. Is it?
So we normally would have 8 because 8 would make it neutral, right? So if I add 2 more to 8, how much is that?
10.
10. So I have 10 electrons. I know it seems so easy when I'm doing it on there, right? Now that you guys have to do it, it's like, what the hell is this?
Okay. Oh, what the?
Exactly.
Let me get my mouse. There you go.
There you go. Okay, so now we need to calculate the number of neutrons. So how would I calculate the number of neutrons? Let me give you a hint. We already talked about it. What does that say there?
Right here, the mass number of protons plus the number of neutrons.
Yes, so mass number equals the number of protons plus the number of neutrons. Okay, so don't I know the number, don't I know the mass number?
Yes, 19.
Okay, don't I know the number of protons?
Yes.
So can I calculate the number of neutrons?
You can.
Okay, so how can I do that?
Do we add them?
So let's do it. So we have 19. Let's put them in the equation. We have 19 equals 8 plus, I'm going to use n for the number of neutrons. Okay. So I want to solve for n. How would you solve for n?
I'm just moving from room.
Okay.
Oh, it's too loud over there. Okay. How do we solve for
N, as in Nancy. How would I solve this equation?
So you don't add them, right?
Nope. So if I want to get rid of the 8 on this side, I'm going to subtract this side by 8. And what I do to one side, I have to do to the other. So if I subtract this side by 8, what am I going to get over here?
11.
What was that? 11. Okay.
Yes.
So 8 minus 8.
0.
Okay. So then that just left me with n. So n equals 11, right?
Mm-hmm.
So my number of neutrons is going to be 11. See that?
Yes.
Okay. So the net charge. So the net charge would be the charge on the oxygen now. So what is that charge on the oxygen?
The -2?
-2. So then we'd write a -2 there. And then the last part is it stable? So the way that we determine it's stable, so what you're going to do is you're going to put in your 8 protons. So drag your 8 protons into this thing over here. So you see your protons, you're going to drag those guys into there.
Oh.
You have to use the mouse to do it. That's 1. Now drag your neutrons. How many neutrons do you have?
11.
11. Okay, so drag 11. Okay, and then drag your electrons. Okay. So now click onto net charge over here.
Right here?
No,
Oh,
over
right
here.
here. Oh. I was covering it with the camera. Okay.
Yeah, click where the button's at. Yeah, there you go. Okay, so does your net charge match up?
Yes.
Okay. Now click over your mass number. Does your mass number match up?
Yes.
Okay, now click on to stable/unstable. Okay, so then that tells you it's unstable. So you want to type in unstable. So you're going to write unstable in your box.
Oh. Can we just do it text like that?
Yep.
Let's see. Oh, wow. Okay.
Yeah, kind of crazy. Well, you're going to make this table on the paper that you're going to turn in, okay? Because you're going to complete the entire table.
Okay.
Okay. So that's what you're doing for the first one.
So every time we do it, we have to clear this thing out over here?
Yep. And the way you clear it out is if you click this button over here, that'll clear it all out.
Oh, right here.
Yep.
Oh,
you got to get the mouse to do it. So you just click that with your mouse.
I'm still on text. I'm trying to take this off. Oh, there you go.
Yeah. Okay. But take a screenshot of each one that you do. So you should have had a screenshot of that one. But I wanted you to do it independently anyway. So.
Oh, man, I did the other one. Okay.
All that hard work for nothing, right?
So do a screenshot
of each one. So
of this one and this one?
Yep. No. You're going to
take this one.
Yeah. So you're going to make this table. You're going to write this table on a piece of paper.
Mm-hmm.
Okay. And you're going to complete the table. So then that way you're not having to go back and forth, right?
Okay.
Okay. I was just showing you this on Zoom by using the annotate. So that's how to do it. Now for the second part here is if we go to symbol. Yeah. So click at the very bottom, it says symbol. If you look on it's called FET, the FET thing, it says build an atom. FET at the very bottom, there's a house, there's an atom. Look on the other side, the other tab, not the lab. There you go. Go toward the bottom. Wait, go down. Go down.
Oh, right here, symbol.
Yeah. Okay. So now for part 2, what you're going to do, you're going to take fluorine and you're going to take, and I said fluoride. That is a big typo. You're going to take, you're going to build the fluoride ion. So basically, you're going to add all of the fluorines that you need. So, I mean, all of the protons that you need. So how many protons does fluorine have?
Chlorine. HSH.
How many
H.
protons? How many?
Well, then do I have it over here? Over here?
Fluoride. I mean, fluorine. Sorry, fluorine, not fluoride.
Fluorine. Oh, 9?
9. Okay. So then you're going to drag 9 protons in there. Okay. You got your, okay, so it tells you what it is. Okay, so now you're gonna drag in 9 electrons because it's gonna be neutrally charged. Okay, and then now you're gonna drag in your neutrons. So you wanna drag in enough neutrons so that you have a stable structure. And the goal is to find 2 stable isotopes. So drag in your neutrons. And then what I would do is I'd hit, you see where it says stable? Mm-hmm. Click that tab. So keep dragging it until you get it to be stable. And you want to find 2 if they exist. Sometimes you don't have to. Sometimes there's only 1.
There you go.
Okay, so then what you want to do is you want to write down the nuclear symbol for that. You see where it says 19F19 and that 0 on the other side. All you have to do is write, you don't have to write the 0 part of it. You just write the 19F9 and that'll be fine.
Okay.
Okay, so that's what you want to give me. So you want to give me 2 of those if you can give me 2 of those. So now add 1 more neutron. Okay, add another neutron. Add another neutron. Okay, so in this case, you know that you can't get another stable isotope. So then what you could do is write the 1, and you would say there's only 1 stable isotope for this element.
Okay.
Okay.
So you want us to print this out, this thing right here?
Yes, you can print it out or you can write it on a piece of paper, either one, yes.
Okay.
And then the last part, the next part is if you go to the 3rd tab, which is game. Okay, so what you're going to do all 4 games. And then you're going to complete the 4 games. They're going to give you your score, your points. So you want to take a screenshot after you get each of the 4 games. Okay?
Okay.
Okay. And then the very last one is that you want to answer this last question.
This one right here.
Yep. So you want to use the notes that we've talked about in class, in lecture. It'll help you answer that question. And I promise you, you will have a question like this on the exam.
Okay.
Okay. On your next exam, not this one that's coming up.
Okay. I had a hard time with the homework. Pretty much I did, I think, okay. There was just one that I had the comment problem with all of them. And it's been kind of like that little monkey on my shoulder because I want to figure out what I did wrong. So when we do the homework, do you usually post in, because I was checking, sometimes it tells you like check the answered, but it wasn't checking as the answered.
No, so the thing is that the homework assignments, they are set up so that you guys can do it multiple times. Right?
Yes.
So you have multiple attempts to get the answer. So if you don't get the answer, then what you can do, you can actually come to me and we'll talk about it. And then we'll see if I can help you figure it out. Right? And so I have office hours. And if you can't make my office hours that day, which is Thursday morning, so from 9 to 11. And then I have office hours today.
At 1:30.
From 1:30 to 3. Yeah.
Okay.
Okay. Just come to my office hours, ask me questions about anything. And then you can also email the tutors and they'll give you their schedules. And they also have Zoom hours that they're available for too.
Oh, okay. Yes, because I'm a visual learner. So I was going through all my notes and I'm like, I'm doing something. If I see it once and then I'll be like, oh, okay. Like I get it. But when I was looking at it, I'm like, I was lost. I'm like, nope. And I did it a bunch of different ways. And I was just not, I used all of my 6 attempts or whatever attempts we had.
Yeah. Yeah, no, like instead of using all your attempts, so when after that 3rd time, let's say you've done 3 of the attempts, then contact me, contact the tutors, we'll be able to help you out.
Okay, good. Okay. Because I was kind of stressing out about those.
Yeah. Okay. Any other questions?
Nope, I don't have any questions.
Okay.
Wait, for the second part, so you want the screenshot of the isotope? I mean, what is it called? My bad, hold up.
For part 1 or for part 2?
Part two.
Part 2? No, I just want the nuclear symbol for the 2 isotopes, if there's at least 2 of them. So I just want you to give me 2 of them if 2 of them exist. If only 1 of them exists, give me the nuclear symbol for that 1. So like, for instance, she had done this one here. This is the nuclear symbol. Let me circle it. My mouse is not working.
So do it, maybe just do the, let me try doing this.
So this
you
would
want
be,
us just to write it down like this. F19, 9, right?
that's right. That's it.
And then on the side, just put 1.
No, that's it. Oh, you're saying next to it, what you would say, you just type in, you say there's only 1 isotope. So there's only 1 isotope.
Okay. Got it.
Okay. So that's what you would do.
Okay, cool. Got it. And I could just take like the screenshots of the assignment, like say for example, like the chart, I could take a screenshot of that and then just keep adding the files.
Yep.
All
That's
right.
fine.
Can I put it in a Word and then just do like the,
Yep, you could do that way too.
just do it in Word and then just do the snipping tool and then
markups.
just put those pictures in there?
Yep, you could do it that way too. And then make sure you use the superscript and subscript if you're putting it in Word or Google Docs. So.
Okay.
Okay.
For the editing, I use the Windows Shift S and it lets you mark it up like as you screenshot it.
Oh, really?
So,
Cool.
Yeah.
I didn't know that.
Yeah, I use that one.
What is it called?
Do you have Windows or Mac? Because I don't know if it's only Windows.
I have both, but I'm using a Windows right now.
Oh yeah, so it's Windows and then Shift, and then as you're holding it, press S, and it like dims the screen, and then with your cursor, just it's like a free like screenshot, like a free form, so you could screenshot the part that you want, and then you can mark it up.
Oh, okay. I didn't know that, so I'm gonna try that. Thank you.
Yeah, for sure. I could, if you didn't get it done, I could show you if I share my screen, or can I share?
Let me stop sharing.
Alrighty.
We have a small crowd today.
Am I sharing it?
Yes.
Yep, you are.
Oh, look, you see how this is how I'm marking it up right now. So for example, I press Windows and I hold Shift right now, and then I press S and it goes into this right here. And then like say for example, I want this part, it goes to there, and then hold up, I have 2 tabs now. Wait a minute. Oh, I had done a snip of the other one earlier. But wait, was I able to do it? Shift, there you go. And then just do that. And then it takes you there, but I don't know why I have so many tabs right now. Why can't I do it now? Is it because I'm sharing my screen? Or is it in the back?
Because you're sharing your screen.
Maybe, huh?
Yeah.
But yeah, like it just gives me a free form like this, and then you'll be able to edit it how I'm making it right now. Yeah, you see.
Oh, okay. Oh, that's pretty cool. I didn't know that trick.
Yeah, I was literally Googling it right now as well. I was like, I remember I was able to do that, but I just forgot the keys. Alrighty. I'll see you guys later.
Okay, I'll see you later.
All right. And I think that's it. Oh, do you have like a couple minutes that I could steal from your time?
Yeah, sure.
Okay.
Are you talking to me or are you talking to?
Yes, to
okay.
you.
Yeah.
Okay. So I think I'm pretty set. I think I'm doing okay.
Mhm.
I don't know so usually what I do, I'll go into modules, and then I'll go into like the things, the tabs. So I think I'm pretty caught up with you. I'm not sure if I'm missing anything.
Let me check. Let's see.
The only thing that I should be missing that I'm going to be submitting today is going to be the last lap.
Okay.
But other than that, I think I am doing everything.
Yeah, I think you're good.
Okay. And then, another question.
Mhm.
I'm really nervous about this class. I don't want to fail it.
Okay.
So I did see that you did give us an option to do extra credit.
Yes.
But I don't see the announcement.
It should have been posted. It should have been that you guys could have done something, an event that's at your campus for National Latino Heritage Month.
Mm-hmm.
So if you attend any of those events, if you take a picture, you should be able to upload that.
Oh, okay, just a 10, and we don't have to write like no essay, nothing.
Yep, that's right. You just got a 10 and show that you were there. That's it.
That event recorded already?
The dancer. What was that?
The event recorded already?
There have been events. It's through the rest of this month. So it's to the 15th.
Oh, okay.
The 15th of this month is the last time that they'll be having events. So I think there's something next week going on. I'll check, but anything that's happening on your campus.
Okay, perfect.
And there are going to be other attempts. Don't worry about it. You'll have many attempts to get extra credit.
Okay, yeah, I'm just one of those people that don't want to get, a bad grade. And I feel like this class is really testing me.
Oh, yeah. This class will test you, It will definitely test you.
Okay.
Okay.
Okay, so I don't have any more questions. And if I do, I'll just go ahead and reach out to you.
Okay. Sounds good.
Alrighty, bye-bye.
Okay,
all right,
take care.
thank you. Bye, have a good one.
You too. Bye-bye.